Today we'll be talking about the cloud-based software, which is the engine behind 3D printing for Markforged. I'm Charles, application engineer at Markforged, based in sunny Watertown headquarters. You might have seen me on a couple webinars this year. Latest that I did was about carbon fiber. If you did join that one, thanks for coming again. Hopefully I don't bore you to death. Ted is our principal software product manager at Markforged, and he currently oversees all of software development. He's the guy that we need to convince when we want a software feature built. You want to say a few words about yourself?
Yeah, hey everybody. Excited to be here and talk about the software story here at Markforged. We have a lot of cool stuff to cover today and a lot of cool stuff we're working on for the future, and getting feedback from you, our customers, is super valuable for helping us to make sure that we're solving the right problems and the most valuable problems for you and your businesses. So really looking forward to today's conversation.
All right, awesome. I've got a note here that my voice is too low. Hopefully that's all right. Cool. Today's conversation will be split into two parts. First, how cloud plays into our capabilities today, and second, what's coming tomorrow. So we've got a healthy set of slides to guide the conversation, but we want to encourage everyone to ask questions. Ted and I have told this story countless times, so we are here to have dialogue. It's more interesting for us. So please jump in and ask questions as you feel. So a little bit about Markforged, if you're unfamiliar. We are based in the Boston area, established in 2013, and a lot of our founders come out of high-tech industry, high-tech educational institutions, and we've been growing very quickly. This is sort of the company slide here, but what I think puts us on the map, and I was just mentioning that we had done a carbon fiber materials webinar last time, or I did. I'm a mechanical engineer, so when I heard about Markforged, it's like, oh, they're most well known for their ability to print strong parts. Today's conversation is not about that. It's about the software that makes that possible. That being said, I'm going to talk about it very briefly. Hopefully that's all right. So we wouldn't be here without the strong materials, and Markforged came into existence to bring the strength of continuous fibers to 3D printing. To give you an idea of the scale of that, the basic materials down here are like Mont Blanc, Mount Kilimanjaro, but if you're familiar with Olympus Mons on Mars, it is an order of magnitude taller than those other mountains, and that's the type of scale where we're at. What is that? To give you an idea what that means, we've got a couple of material samples here, and in comparison and under flex, and you can see that fiber reinforcement adds a lot to the material, to the point that a fiber reinforced beam could be stronger than aluminum. And what that means also is that we have the ability to vary the amount of fiber in the part and give you variable strength. How does that work? Check out the carbon fiber webinar. I think we have a recording. But in general, this is what you would see as a printed part. Inside, we're putting continuous fiber. So we're pathing it with a separate nozzle, and it's adding strength in the direction of the fiber. So if you imagine that fiber being that strengthening mechanism, it's all inside the part. And, we fill that part up, close up the top, and there you have it, a part that is strong. So it's a new type of material, and the complexity of printing meant that we really quickly hit the limits of readily available software, and we needed to develop our own. Generally hate to admit when he's right, but David, our founder and CTO, co-founder, make that clear, made the right call to develop Eiger natively in the cloud. Earlier on, I think it could have been faster to just to write code off the cloud, but we built natively, and that decision, which was made on early in the company's infancy, has made a world of difference for our ability to develop software and also the overall experience for our customers. So we now have the world's largest fleet of online printers. And what we're driven to do now is make a 3D printing ecosystem that's comprised of hardware, software, and materials And every component of that system really is built to work together to be smart, robust, simple, and empowering. We call that system the digital forge, which, because of our tight integrations between the software, hardware, and materials, means that we can bring the power of agile software engineering to the world of industrial manufacturing. So I want to ask a few questions of you, and I'm going to flip the script here. Normally the questions come in. Before you have questions, I'm going to ask you some questions. So we're going to use the polling feature of Zoom, if that's all right, and feel free to participate or not. It's up to you. I'm going to do about a minute a piece, and there will be 3 questions. So first up, we want to get a sense of what 3D printing technologies you use. So I'm going to throw up the poll here. You have about a minute to answer this, and the question is, which 3D printing technologies do you use? FFF, FDM, which is the extrusion-based stuff, SLA or DLP, which is resins, SLS. I would consider SLS for plastic SLS, so powder, and then DMLS is direct metal laser sintering, so metal, MJF, multi-jet fusion. So we're seeing some results. And select all that apply. So if you use multiple, you are living the dream. Cool. Got about 10 seconds. Final answer. Buzzer beater. Okay, we made it. Thanks everyone for your votes. I'm gonna end the poll now, and I'll just do a quick share here. Don't worry, it's anonymized, so we'll share the results. We've got 70 out of 100 people who responded said that they've used FDM. Next up, SLA, so resin-based systems, and then we actually got an interesting, like a declining curve here, SLS, DMLS, and then multi-jet, but 10 others. I'm very curious what your other is. If you want to throw that into the chat, if you have an other, I am interested. So cool. I'll stop sharing those results, and we will move on to the next poll question. So of the 70 out of 100 responses that we got, which FFF printers do you use, if any? And these are just a list of the top brands that we've seen, not in any particular order. And I'll throw that poll up real quick. So the brands here, Markforged, that's us obviously. If you're a current customer or you've used our printers, thank you. I hope that this will be rewarding for you after we get through the poll questions. And even if you use these at home, that's totally cool too. We tend to focus on printers at work. Because that's where most of our customers are, but if you print at home, that's awesome. Here we go. Let's go other category. We're growing. I must have missed some. I'll answer a few questions here. Are there printing parts as service providers, or do you need a printer? For us, we have a number of service providers. We don't provide that service, but some of our customers do. So if you're not quite ready, we can put you in touch. If you just reach out to us on our website. Another question here. Other is not doing 3D printing yet. Michael, that's great. And thanks for being here. Greg, PLA considered to be SLS. PLA is, I would say PLA is a material that would be used for FFF or FDM. Oh, got a Rapidia user. Cool. All right, so we're over the minute. Thanks everyone for answering. I'm gonna end poll here, and just do a quick share of the results. We've got quite a spread of people here. So what I'm getting from that is that people are using a variety of printers. Cool. Last question. What 3D printing software do you use, if any, of these? And I think this is going to be biased towards FFF printing because that's the category that we're in. So let's see. Launch this poll real quick. Oh, Leo said that you can only select one printer in the survey. Sorry about that. Must have been a mistake on our end. Cool. Ted, any surprises here? We're seeing a lot of Cura users and a lot of other users. I'm going to end the poll shortly. 3, 2,
Yeah,
1.
I'd be curious to hear more about what other is. I think this lines up a little bit with the poll you did on what machines people are using. So I think it's in line with that.
Yeah. Cool. We've got a diverse set of skills out there in our audience today. So thanks everyone for sharing. This is interesting information for us, and hopefully, as we go down the line, if you have questions that are pertaining to these softwares and are pertaining to ours and how they differ from yours, we can help answer those. So stop sharing those poll results and move on. So the question that we are going to ask here is why cloud, and we'll try to answer that question as well. There are a number of obvious answers to me as a mainly a user of 3D printing. Ted's the one back in developing it, and he knows the ins and out of the cloud. But for me, the obvious answers as a user are collaboration. Right? You can collaborate with multiple people. You have different job sites. You connect to the same cloud for the data, and if you want to share files, you want to share print jobs, you want to share information about print jobs, it's all available on the cloud. So that also means that there's some instantaneous access to digital inventory, which could maximize your utilization essentially, because you now have a wider range of parts that you could print without having to manually make them all yourself. There's also instant access to new updates. So that to me means that anytime Ted pushes something out, like a new feature, I get it immediately. I don't have to download anything. I don't install anything. But there are a couple that I thought were non-obvious to me. So Ted, I'm gonna pitch these to you. Tell us a little bit more about what else makes the cloud interesting.
I'll start with my favorite. The cloud is more secure than your laptop. The cloud, it's convenient and it's secure. Markforged, our software team, our company has invested quite a bit in building the most robust security stance of any company in manufacturing. Not additive, but manufacturing. We're the only additive company to have our ISO 27001, which is a series of procedures and independent audits and reviews of how we write code, how we ship updates, how we protect your data. And how we do things like audit our own suppliers, how we do building access, how my laptop is secured, how Charles' laptop is secured, what we do in the case of an emergency. So like we spend a lot of time thinking about how we can provide all of those user benefits in a way that you can, feel comfortable and have the proof, the attestations and certifications from an independent review board to show that we're meeting that. I always think back to, there was a time where I was traveling for work and my laptop got wrecked on an airplane. Somebody was jamming their luggage in and my laptop got destroyed. I showed up to the office, they handed me a new one and I was up and running in minutes. All of my information, because it's not local, is more robust, more accessible. and from anywhere I need to be. So that's kind of how I start. And then, like Charles said, the over-the-air updates, our ability to take our fleet of thousands and thousands of printers and bring them some of the updates we're going to talk about. We're pushing software to our printers on a weekly or biweekly cadence. We're pushing software updates to Eiger daily. As features are developed, tested, and available for general consumption, we push them out to you. There's no barrier other than maybe refreshing your browser. And we're trying to make this easy so that you can take all of the benefits of continuous strong functional parts with continuous fiber reinforcement, metal parts, excuse me, high accuracy, highly profitable parts, hopefully for your businesses, and be able to have that experience from anywhere. When COVID hit, a lot of our customers were able to, I have a couple printers here, pick their X7 up, throw it in the back of the truck, bring it home, keep working. If you had to keep your printers in the office, you can run them from home and just go in when you need to change the bed out or to do whatever maintenance you might need to do. So that kind of flexibility and robustness to the platform is really powerful. And because we approach this in a cloud native format, you get all of that, bundled in with all of the other values. So it's really exciting, both what we've been able to do. And again, we'll talk maybe a little bit about some of the things that are coming, and how this platform continues to get better and better over time. And customers are really seeing the benefit where, if you think about your printer, the day you buy it is maybe the worst it's ever going to be. It's going to get more accurate. It's going to get faster. It's going to have new materials. It's going to have this ever expanding portfolio of capabilities, so that you can make sure that this is a platform that when you invest in, it comes back and it brings you that value time and time again.
Awesome. Cool. Thanks, Ted. Now we'll be going into a bit of some of the things that we've worked on and have been added to the Eiger platform. So we call this the evolution of the deployed fleet. So normally if we are pushing out updates, imagine we push out a small update. That means that everybody's going to have to update their security settings, and they're going to download a file. There are going to be discrepancies between those softwares. And the way that we've taken the approach is that we want the updates to be out in the fleet as soon as possible. So here's a bit of a timeline on, the text is a bit small here, but here's our product development over the years. And you'll see that as time goes on, we've added products, but we've also pushed updates across the platform. So we're bringing the machine along for the journey. And I think this was recently, maybe this was either Ted or David that had said this. The first day that you get the machine is the worst that it'll ever be. The machine is continuing to get better with time as we add capabilities through software, and that's all possible and made accessible to you by the cloud. This is our flagship industrial printer, the X7, and there are a number of things that have improved and changed on this over time. So the build volume, for one, is something that we have made larger over time. We enabled a different area of the print bed to be used, and that was all through software. We increased the range of print resolutions on this machine. Early on, it was 100 micron to 200 micron, and now we've got 50 to 250. So we can get finer through different type of software tuning, but also go faster. We've been able to improve the accuracy and add things like automation, utilities onto the machine, speed the thing up, and add materials that are qualified for use on the system. Some of those things that you might have seen, if you're a current customer, are that we've improved our algorithms for printing. So on the top here, you'll see a situation where users were noticing pinhole defects on very small sections of part, of roofs specifically, as it was filling in. And this is something that normally, if you had a hobby printer, Ted, I think both of us have a hobby printer at home.
That's right.
These are types of things that you'll see where you would say, okay, well, let me just go adjust my retract settings. Let me go change my extrusion settings. And you're gonna have to do that for every single material. Each time you choose a new material, you're gonna have to do that. If the feature is a little bit different, you might test and change that. But we're doing a suite of test prints at Markforged to make sure that you don't have to do that tuning. And we're applying that across a range of materials so that you can just trust your machine to do what it needs to do. So you'll see before and after the effects, and that's going to apply to every material that we make. A similar type of thing that we did here, we call these tiny island under extrusions. Tiny, I get a little dream of a tiny island whenever I hear that. But it was an area, it's the same type of thing where we weren't quite putting the right amount of material where it needed to go. And through software fixes, we were able to quickly apply that and deploy that to every user of the platform. So on the left before, on the right after. You can see that got a lot better. And we've also increased the resolution of the print head. So we say that as in, if you think about the bead of a FFF printer, we're printing in a single bead the width of the nozzle. And that was generating some problems that you can see on the bottom there, the bottommost part. And you can see that there's a bit of a gap in there. And what we were able to do through software is to fill all those little voids. And you can see the results on the top. There's also speed. This one has been one of my favorites. Not every part that I make is one that needs the finest resolution, that needs to be the most, like the most pristine. But we were able to make an adjustment in software to enable our printers to print way faster. So taking our default time from 2.75 hours, like the fastest part that we could make, 2.75 hours, to 1.5 hours. And we shipped the setting live to all of our industrial series, to all of our X7 printers in 2019. And that overnight enabled them to print twice as fast. And well, here's one of my favorite tools, and I want Ted to talk about it. We're gonna have a little TED talk about the primitive maintenance tracker. This one was a long time coming, and has helped me a lot in being able to keep my machine going. But Ted, like, why do people ask for a primitive maintenance tracker?
Yeah, sure. So these machines, when properly maintained, are excellent. But because they're so excellent, sometimes people forget to do the maintenance. It's not obvious when boat and tubes start to wear, or when you might need to, tighten different bits or apply grease or different things. There's a whole preventive maintenance schedule that we propose with the printer, that we provide with the printer for you to follow. And we were finding that it was kind of a challenge for our customers to come up with a process to, if they didn't have a good preventive maintenance system in place to manage that. So you'd wind up with sticky notes, or you'd wind up with spreadsheets, or you'd wind up with emails reminding people, hey, go do this or go do that. And so what we did is we took all of the consumables that the printer uses as part of its normal operation. We put them on a schedule, whether it's hours of operation or whether it's amount of material, depending on how the component wears over time. And we put a simple tracker into the printer. This allows the printer to tell you, raise its hand and say, hey, it's likely time for service. You've exceeded the service life of this component, and then provides you with the right utility to guide you through how you do that really, really easily. The whole thing here is just about making it easier to get the value out of your printers and keep them running, keep that utilization at maximum, and you can start to schedule and plan out when you're going to do your maintenance in between jobs most effectively, and just make it easier.
Yeah, it's it for me has just made tracking things a lot easier. I was keeping track in a notebook before, and now the machine takes care of itself, right? It's telling me that it needs a new tube, and I might not look at it and think immediately, oh, that needs a new tube. But when I look at it a little more closely, it's like, oh, okay, the tube is wearing a little bit. I can see that, but I wouldn't have noticed it. I probably would have waited until I had failed to print. So this keeps you from failing prints and keeps the machines running at tip-top shape. We've also added new materials. So some of these are near and dear to me. Onyx ESD is widely used in the electronics industry, and this was something that we got questions for very early on. Onyx is a carbon fiber reinforced nylon, so it's small chopped carbons. And one of the first questions that I would get a lot when I joined the company was, well, it's got carbon fiber in it. Is it ESD safe? And the answer is Onyx itself is not, because the surface resistance range that you need for ESD safety is actually quite tight. And so there are other additives needed in order to reach that. And we developed a new material to address that market. When people ask us for a new material, we're listening, right? And if you've got a real use case for it, and the electronics manufacturing industry sure does have needs for 3D printing, we were able to develop new materials and then push those out to existing customers that already have the printers. So if you're using this for fixturing at one part of the plant, now you can use it for electronics fixturing in another part of the plant. And that's something that we saw happen at a number of customer sites. Not only that, it's also stiffer and a bit stronger than Onyx. Onyx FR is a UL94V0 rated material, and that's capable of being of reaching FSD compliance. So this is a material that potentially could be used in aerospace applications. This is also a material that we rolled out after a machine was already launched. So we're developing new materials, but we're also making sure that they work with the systems that you already have and that they work robustly in the way that you would expect with those systems. I do see a couple of questions. We'll as soon as I wrap up here, we'll have a little halftime Q&A session. So this is the last slide before the Q&A, the halftime Q&A, not the full one. So automatic build plate packing is also something that we got a lot of requests for. So whenever I'm printing a large number of small parts, having to manually move them around on a build plate is something that just frankly, like I don't want to do all the time. We built in algorithms to automatically place parts on the build plate so that you didn't have to do that anymore. So these are just a few examples of types of features that we've rolled out. Over time, we've also improved security. We've increased the number of features, the number of options that you have, giving you the right options based on what you need, not necessarily giving you the full suite, and keeping Eiger very tight and still very easy to use. So we're at halftime. We're gonna do a little halftime Q&A here. So I see a number of questions already. So let's see. Michael wants to outfit a sailing yacht for global cruising with 3D printing capability with material and printer. What would you recommend? Ted, you're a bit of a sailor yourself.
I sailed professionally for a while, and for a long time ago, I was an officer in the U.S. Coast Guard, working on medium endurance cutters up and down the eastern seaboard. I guess it depends on what kind of parts you envision printing. Are you going to be printing blocks and tackles? Are you going to be printing underwater components? Are you going to be printing engine components? And then what kind of size and power do you expect to have in storage? Yacht is a broad term. I could say, let's get a Markforged X7 in there, or maybe a Prusa Mini makes more sense. So it really depends on the specific applications. There's not, in this industry, there's really a lot of things. But I'll say if you want to have strong functional parts and an easy way to build them reliably, maybe take a look at a Mark II. Yeah. If you're looking at like Jeff Bezos style yachts, like let's talk about Metal X's, and maybe you can have a sinter oven on there and it'll be fine.
Yeah, Michael, get in touch with us on our website. We should be able to answer your question, help you figure out what exactly you need, what type of parts you need. I think Ted's options are great. X7, Mark II, those are great options for composites, and I think that'll take you a long way. They also use actually a lot less heat. As I realized, like all my hobby printers also plugged into my UPS, and I noticed that because of the heated bed that they draw a lot more power than my X7 does. So it's also quite conservative as far as power goes. So let's see. Mike has a question here. Can you help us understand how rights are managed, both for the equipment and printers and the software? Would like to know how we can assign specific rights to users at one or multiple sites. And Ted, this is also something that you've been working on a lot recently. Do you want to?
Yeah, absolutely. So we have some capabilities that are not quite released yet, but are in beta testing with a set of customers where you can exactly what you're asking for here, which is role-based access control. So I think later this year, you'll see us unveil some new management features that will help you to scale your solution, where you want to have maybe an engineer that can design parts, but not necessarily operate the printer, and a technician that can operate the printer, but not necessarily design parts. And depending on what your factory or machine shop or whatever situation you're in where you're engaging with these printers, we can provide you the tools to build out the right kind of management structure and oversight that you're going to need to have. So definitely something that we're working on today.
Yeah, and for me, it's like I think anytime I see a new user at our organization come on board, we provision them a license, and then when it's time for them to move on to a different company, they will also get their license. Just it's a quick switch. The admin is able to modify and update those as needed. Cool. Let's see. Got some other questions here. A question around consumable tracking. Will this feature limit the actual lifetime of the part? So Alfie's question says that I've seen 3D printers not indicate you need to replace your tray, so replace to continue. However, the tray is okay. So the strategy is usually made to get people to buy consumables, even though the ones that are installed are still in good shape. I'm notoriously bad at following the tracker. Like I use it as a guide, and for certain things like the tubes, I definitely replace the tubes. But it's more like you look at the tracker tells you when the acceptable lifetime is up, and if you want to use it for a little longer, like it's then up to you, right? If you decide to run a print with a worn tube when the machine tells you there's a worn tube, like you can do that, but like it's sort of like not getting an oil change when your car tells you to. You may end up paying for that later.
Yeah, you can actually, so it certainly doesn't block you from doing anything, and you can snooze it and it'll just come back up sometime later. So there's intervals where you can kind of like hit the snooze button and try again later.
Yeah, I certainly think that there are ranges of use cases for us. For the most part, I think it's pretty accurate. Like the Bowden tube for me twice at this point it's thrown the tracker and said like, hey, it's time for a new tube. I said no, it's okay. 2 prints later, it's okay. Like, all right, it was time. I see it, and it's nearly worn to the edge there. Cool. Let's see. We got a number of questions around the machine itself. I'm going to save those for answer an email because we're focused on the software today, and we've got Ted's time. So let's see. Why can't you host the, Mark has a question here. Why can't you host the software on the machine or on a local network computer and update it remotely, similar to how other software on my computer is updated?
Sure. That is a way that some companies build their software. I think there's a lot of complexity and a lot of edge cases that get introduced there, and our focus is on delivering value in the most efficient way possible. Today, not to preclude us from doing other things in the future, but when we were building this company, we wanted to, again, focus on providing the most value and solving the most important problems. By having a unified architecture, it hosted on a single cloud, that allows us to make sure that every customer is running the same instance of Eiger. And when you have things like a support issue, there's none of this like, oh, you're on version 7, but we're on version 8 and you haven't done the update. It just creates the opportunity for a lot more failure modes. So this simplifies both the cost of us building things and increases the speed with which we can deliver reliable value to the customer. So it's a conscious decision that we've made to simplify the architecture, but there's definitely other ways that some of these problems can be solved.
Yeah. Sweet. Cool.
One more plug for security. If there is a critical security patch that we have to roll out because we've been notified about an issue with an underlying library or whatever, that we have the complete control to make sure everybody is updated instantaneously and we don't have exposure to older versions running on an on-premises solution, like you kind of open yourself up to when you have that hybrid model.
Yeah. Cool. Let's see. I got 2 more minutes before I'm going to move on to the next set. Quick lightning round here. Prabhakar asks, can they be connected to edge devices for remote monitoring? So this feels like a question around like open APIs or connecting to other devices.
Yeah. So today you can monitor in Eiger. We have device monitoring, and we will be looking at opening up integrations with other systems so you can monitor it through like an MES type system down the road. So stay tuned for more on that.
Yeah, and if little plug here for anybody who would like a software demo, we have a number of reps that can run you through a customized demo. Our website actually, I think, may do a better job than I do at demoing the software. So if you want to go to markforged.com, Iger or the software link. Let's see. It's a really nicely put together page, and it's got a couple screen cap videos of what a typical workflow looks like. It's a dead simple. So check out 3D printing software. Just click on software, and you'll be able to see that. So you'll see a nice cool video. But these are actually Daniel Leong, one of my colleagues, using the machine to print a part. So we've got a number of those workflows already documented. So check those out, and if you want to learn more, reach out to us. Cool. So, all right. I'm gonna move on, and before we run out of time here, we got one more thing that we want to cover. This is something that Ted's been working on a lot, and we'll answer the rest of the questions in the last 10 minutes. So thanks for sticking around. There are a number of questions here that I'm going to do a quick poll for. I'm not going to do the full minute, just 30-second poll here. So where are the colleagues that you primarily collaborate with? Same facility, another facility, or that you work on your own? You'll be able to quickly select this. You got 15 seconds. This is mostly to figure out whether cloud is relevant for everyone. Well, in the context of collaboration, there's still relevance in security and updates as we described earlier. So 30 seconds. Thanks for your answers. I'm going to end that poll. And so a lot of people I'm seeing here work in the same facility or work on their own. So we're seeing same facility, work on their own, and 10 people said they work at another facility. Cool. Let's see, poll question number 5. What's your primary role? This is something that we I think it would be interesting to see if there's any correlation. Seeing a lot of design and engineering. Number of academia, that's cool. All right, 5 seconds. All right, that's it. Yeah, so large number in design and engineering, as I would expect here, but also R&D, and we've got distribution through production and quality, and then academia and education. I imagine we have been talking to a number of schools and institutions. So thanks for your representation, and a number of others. So if you got another that doesn't fit in these categories, thanks for fighting the good fight. I feel that sometimes, and feel free to share with us what you do. Cool. Our last question of the day before we get on to talking about blacksmith. How do you inspect your parts? Inspect or qualify. This is anybody going to admit that they don't? These are for AM parts specifically. So it is okay. We're not going to shame here if you don't inspect your parts, because I often do not. I kind of just trust the machine to do what it's supposed to do, and I'll send it out. Cool. We're just about topped out on responses here, so I'm going to end the poll in 3, 2, still coming in, 2, 1. All right, end poll. This I think it is probably correlated pretty well with just overall inspection. A lot of people do manual inspection, right? And I do this. I've a set of Mitutoyo calipers at home as well, so I do that. But interesting to see. Thanks for everyone else who who responded with a CMM. I think CMM laser marking, like CMM fixtures are awesome. Laser scanning fixtures are also quite awesome. And then those are things that we could print. And then for the number of you who admitted that you don't, very brave of you. Thanks for responding. Okay, cool. So the industrial series printers are equipped with a laser, and we equipped that very early on, and it was a decision that was made by our product team to add the laser. And the idea was that it would add a host of capabilities to the machine, but at the time we weren't so sure what it was supposed to be used for. So a year after we shipped this hyper accurate 1 micron inspection laser, it was upgraded to improve the printhead alignment. So we used the laser to align the machine. And over the course of time, we kind of worked with a different type of inspection. And finally, I think we're at a place today where we are happy to share something. And that's blacksmith for the X7. So the blacksmith process, in a nutshell, is that we calibrate the machine using the laser. We have an in-process laser scan for the part, and that scan data is compared to the STL. So we take those data points, we compare to the STL, and then we can then generate some print reports regarding the accuracy of the part. So what that looks like is this. So first we do a scan. So we base this scan on a very precisely machined bed, that calibration bed that we send out. And this ensures that the printers are in peak condition, and we use this OEM certified reference bed, which is inspected before we ship them all out. So first we inspect, the first step of inspection is to calibrate the sensors that you're using. So
one note on that reference bed, Charles. That reference bed is manufactured to very, very tight tolerances and inspected itself with a CMM. Each reference bed has a CMM file that's uploaded to Eiger, so that when you calibrate a blacksmith printer, it's calibrated to your specific reference bed, which helps us to ensure that we are using software to solve for any kind of hardware inconsistencies or anything that might happen in the physical world. I think Richard was the one we were in the chat talking about how can you use software to improve resolution and accuracy. The first thing is by setting a set of coordinates that allows us to do transformations to compensate for things like backlash or skew or any kind of offsets that might exist in the system. So this is a critical piece of what makes blacksmith work and helps make these things better.
Yeah. So after we've calibrated the printer using this precise, very precision machine bed, we then go into in-process scanning. So as a part is printing, you can see here on the image on the right that the laser is able to take data points on the part itself and form its image of what the part looks like. So that means that it's actually, in the past, we'd experimented with scanning the whole part, and using a point laser, that could take a long time. So we were actually intelligently generating a laser inspection toolpath to get good coverage using a reasonable amount of time. And that scan completes automatically with minimal impact to the actual overall print time. And after that, we take that data and generate, well, Eiger and Blacksmith generates its image of, its 3D image of what it thinks the part looks like, right? It's got the sensor now, and it has the ability to detect. And so it's giving you an output of what it thinks the part looks like. So it creates a 3D point cloud that corresponds to the measurements taken on your part, and the point cloud is overlaid with the STL for comparison. And with that, you can generate reports. So based on these data points, you get the ability to assess and monitor print quality. You can select places where you have critical tolerances, and that helps you understand if you've met those specs or not. And you can also view historical scan data to have traceability on your parts. So over time, are those parts staying in spec? Between different machines, are those parts staying in spec? And with that, you'll also get statistical deviations, like distributions of a part, to see if they're within tolerance. And here's something that I thought was super cool, and I think is coming soon or is already out, Ted?
Out today. Go buy Blacksmith. Go inspect your parts.
Yeah. Feature inspection. This is wild to me because normally I look at this and I'm like, okay, this is a part with some edges, some square edges, and I think, oh, like I'm gonna take point cloud data. The last time I did actually laser inspection, it was sort of like, okay, well, I'll scan this and then define that this is a flat surface. There are certain softwares that cost a good deal more money that will do this automatically, but we include this like built into Blacksmith. So not only is the scanner already included with the printer, it's software that costs a fraction of what it would take on an annual basis to get a comparable product. So we can see the distance, the angularity between surfaces, and we're expanding that, right? Like as we're getting smarter and our software team is developing more features, we're gonna be able to expand the type of inspections that you can do. And we're generating a print report, and you can then append different types of inspections that you wanted to do, different measurements that you're taking to the report. And we've got that coming out soon, right, Ted?
That's right. So today with planar features, we can do the distance between the angles. You can get a lot of statistical information about the points on that feature. How many points were there? How many were in tolerance? Which is really interesting as that automated feature detection feature is expanding. So we'll be doing support for circles and cylinders and spheres. So you can know how much of a circle is this circle or how much of a cylinder is this cylinder. And then what is the distance between center points and offsets and things like that, which can then be appended to this report. Once you've gone through and indicated the critical dimensions you care about for a part, we will then be able to automatically regenerate that for every instance of a part that you print afterwards. So you can kind of go in and say, on this part, I care about the distance between the center points of these two mounting holes and the height of the overall fixture, if it's a jig for assembly, for example. And then Iger and Blacksmith will learn on that and will help you to automate that process. So really exciting already to see the features that have come out just since we've launched this very recently, and we'll be continuing to expand on all of these things.
Yeah, and in short, what Blacksmith is giving you is verified parts off of the print bed, and that means you get known good parts wherever you're making them. So a machine here in my apartment here in Somerville is going to print the same as a machine at Ted's place, is the same as a machine at Masa's place in Tokyo, is the same as a machine in the print farm at Watertown headquarters. And it's going to be built with an accessible and integrated workflow. So that in-process inspection is done with one click from the printer. So it's you just toggle on. You want this, and it's in there. And what that gives you is confirmed fleet conformity. So as I was saying, across the fleet, between different printers, you can print confidently and know that the parts that are coming out from each printer are the same. So when you have a deployed solution where you need parts to show up in existence in 50 different locations, you can do that and trust that they'll be right. And a bit of a disclaimer, but also a bit of a hopeful note for the future. Blacksmith is a continuously evolving product, and we're adding feature and functionality regularly. So like all of our products, Blacksmith is the worst that it's ever been today. It's only getting better. Cool. So we've got about 7 minutes left and a number of questions. Thanks everyone. And if you have more questions and we don't get to them in time, we will definitely follow up via email. Thanks everyone for joining today, and we'll get started on these questions. Let's see. Is the software subscription based, or is it pay once?
So the Iger software that we talked through today is bundled with the price of your printer, so you get that license. Blacksmith is sold as an additional software subscription license, which is $10,000 per year per printer.
Cool. If you lose local internet access, will you still be able to print?
Sure. So once the printer kicks off its print, it has everything it needs to continue and finish that print. So you don't have to worry about any intermediary interruptions interrupting a print. And then we do have a USB port on the printer, so you can actually export your files from Iger to a Markforged print file format. Maybe people that have been around manufacturing or around 3D printing know about G code. This is not G code. This is a encrypted file format that's uh, protects your part data and only works on Markforged machines, so nobody can like reverse engineer or inject bad data into your part, which is great. So you can download those and then just have them on USB stick if you're worried about if you're going to like pack the printer up in a car and go camping with it or something. You can load up all the prints you might want to have on a thumb drive or a hard drive and print that way.
Yeah, and this is a little bit of anecdotal evidence. I've taken printers to different places as part of demoing the machine or printing parts for certain customers, and it's a lot of those places have had pretty spotty Wi-Fi connections. But whenever I can get a good connection, I'm able to send a print remotely. I'm not sure I'm supposed to endorse this, but I've done it from my phone, and it's it's like
It's fine.
yeah, it's fine, and it sends the print as soon as it's finished downloading the whole part, and it's like it's like all right, just start the print. That's that. The file's transferred and it's on the printer.
Yep. And you can even queue up many prints to a printer from the cloud. You can say, here's the next 10 prints I want you to do.
Yeah, yeah. Let's see. Will software handle part serialization? That's a good question.
It is a good question. Not today, but it's something that we're thinking about for sure.
Yeah. Is there a latency and bandwidth specification for the cloud-based software to communicate with a printer?
I don't have a minimum. Like Charles said, like it doesn't take a lot of bandwidth. I'd be surprised if you came across any kind of network where it won't work. Eventually, the downloads of files might be a little bit slow, but that's physics. But the printer itself doesn't require a huge amount of bandwidth.
Yeah, if you're still on dial-up, that could be it might take a few minutes, but even still, it's like depending on it's a physics thing. Depends on the file size and so on. Is the data available on the cloud for Blacksmith? I suppose for Bakker's question.
Yes. Yeah. Everything that Blacksmith does lives in your Iger account. So there's when you purchase Blacksmith, you get a new Blacksmith tab. You can go in there and manage all your Blacksmith builds and all your Blacksmith build data directly in Iger.
Yeah. Mike Kuno has a question. You mentioned that the in-process scan has minimal impact on print time. Can you be more specific on timing impacts, please?
Sure. So we when you set up your Blacksmith print job, there's a range of scan resolution that you can select: low, medium, and high. At the high resolution on most part geometries, we've seen an increase of about 8% in print time, and that allows you to resolve features down to I think it's 2 millimeters. That allows you to resolve 3 millimeter features with plus or minus 30 micron accuracy. And then there's a low resolution, which allows you to resolve 12 millimeter features with plus or minus 120 micron of accuracy. So you get to decide, how small are the features you're working on versus the time that you're going to add to print. And we're talking at the low resolution, it's an extra 2% to your print time. So that trade-off is entirely in your hands.
Yeah. Cool. With Blacksmith, can you change the measured area of a feature, for example, move away from the feature boundary? Luke, I'm not sure I'm fully understanding your question. If you're still on, if you wouldn't mind clarifying with the second question, if I'm reading it correctly, can you change the measured area of a feature? So if you wanted to, like, measure an offset from a surface, and have that be the number. I think right now we're saying like absolute measurement, and we're actually interpolating a lot of data points, right, to get you what a surface is.
That's right. So today we have a uniform, a randomly sample uniform, they're semi-random, semi-intelligent sampling of the part at very high density, and so we can do different kinds of measurements later because we're capturing the full point cloud. Applying different measurement algorithms to it is kind of trivial. So that's what we're working on right now. So if you have a specific example you want to talk about, please reach out to us, and I'd love to hear the use case and how we can help. Write an algorithm to help measure whatever it is that you want to measure with Blacksmith.
Cool. Luke, thanks for clarifying. So Luke says, for example, inspecting the profile of a surface with a boss extrude. Okay, so with a boss extruded from it, but you don't want to pick up the fillet at the base of the boss. So
I see.
he's trying to say like, yeah, okay,
Yeah.
ignoring certain parts of it. Yeah,
Yeah, and you could, because of the way the algorithm works, it would actually separate those into kind of like, if there's two pieces of fill between them, it kind of separate that into three part regions, so you could measure to any one of those pieces.
cool. Let's see. Are printer updates also available to be downloaded and then brought to the printer to be updated via USB? James Marlin's question.
Yes, you can go into Tiger, go to the downloads page, and download your the latest available printer updates. We post them there at the same time to push them out to the fleet.
Manoj has a question: is the software subscription based for Blacksmith?
For Blacksmith, yes, you can buy a one or multi-year subscription. Yeah,
Yeah, and Iger actually right now is included. I think we have free software for slicing, so it's you buy a Markforged printer, the software is included. I think are we considering like advanced features like for subscription? Is that something that we're thinking about?
I don't know, maybe.
Maybe.
Yeah. So anyone can go to Iger today, create a free account, poke around. When you buy your printer, then you get a license included with that printer to slice with the materials available to your printer, and print them out. No comment on future things.
Cool. So yeah, it's totally free to use, and even if you don't, if you don't have a printer, you can still get a trial license right now. So if you want to go see it, just go to the Iger webpage and request a trial. And we'll also send out a link to the Iger trial in a follow-up email. So yeah, thanks for all your questions. I see a number of like very specific application-based questions, which I don't think we're going to be able to get to today, but we have your question noted, and we'll follow up in an email directly related to your application question. Let's see. So I think that's all the questions on software that I've gotten. Thanks everyone for coming today, and I'll leave you with this beautiful image of the Digital Forge. And it really is the combination of software, hardware, and materials that brings us all together. And I appreciate everybody coming, and hope this was informative. If you have any additional questions, please feel free to reach out. Cool. Thanks everyone.